Good morning, students. From today's class, we are going to start with a new chapter, that is some basic concepts of chemistry. Okay, so this is the very most important chapter for you. If you completely understood this chapter, you may answer so many chapters in this year as well as next year. Completely basic. For each and everything, you need this. Okay, so this is the very first chapter of your syllabus, that is some basic concepts of chemistry. Okay, so students, this chapter carries 8 marks. 1 marks 1 question, 2 marks 1 question, and 5 marks 1 question. So this 1 marks question is question number 1, this is question number 11, this is question number 27. Understand? In the question paper I am telling. Question number 1 is from some basic concepts of chemistry. Question number 11 and the question number 27. This is the 5 marks question. It is 3 plus 2. Understand? Okay. As I told you before only, in chemistry there is no direct 5 marks question as in biology, physics and maths. You know, directly in biology they'll ask any one diagram for 5 marks directly. In physics, they'll ask any one derivation from 5 marks directly. Correct? So in maths also, of course, based on the formulas, then 5 marks question is there, 6 marks is there, 11 marks is also there. Understand? But in chemistry, there is not even 4 marks. Only 3, 2, 1. So 5 marks question means they'll split like 3, 1, 1, 3, 2, or 2, 2, 1, like that. Okay, so that means whatever the questions are there, only 3 marks and 2 marks. Okay, so this is some basic concepts of chemistry. So in this chapter, what we are going to study means initially, so classification of matter, especially chemical classification. So matter is classified physically as solid, liquid, gases. Similarly, it classified chemically in different ways, like mixtures are there, pure substance. In that again. Classification are there like compounds, elements, okay, heterogeneous mixture, homogeneous mixture. So the type of classification is there. That is we are going to study in this chapter. Very first thing. Next, what is the relation? Means unit and the fundamental units. For length, what we are using, okay, for luminous intensity, for kg, mass we want to say means what is the unit. The 7 basic fundamental units are there. Those we are going to study in this chapter. Initially classification, next fundamental units, next the terms. Like means if they say milligram, you have to take 10 raised to minus 3. Understood? Macro 10 raised to 6. Micro 10 raised to minus 6. Angstrom 10 raised to minus 10. Do you remember? Nano means 10 raised to minus 9 meter. So that type of different quantities are there. For which power we are naming that. Means what is called as milli, what is called as micro, kilo, centi, deci. Understand? So those quantities are there. So after that, students, scientific notation and also significant figures. What is the scientific notation and significant figures? Means and write first the objectives of this classification of matter first. Don't write classification of matter. Second one is fundamental units, fundamental physical quantities. Fundamental physical quantities. Next, powers and their prefix. And next, scientific notation and significant figure. Significant figures. Okay, next, different laws respect to masses of the substances. Means law of conservation of mass is there, law of definite proportion is there, law of multiple proportion. Okay, different laws with respect to mass of the substances. Okay, and Avogadro's law is also there. As I told you while explaining the Avogadro's law, I said in the chapter some basic concepts of chemistry, we will derive the term 6.023 to 10 power 23, right? So that's what we are going to say it. In these different laws, 4 laws will come. Later I will explain. Next, after that, calculations of calculation of molar masses. Next, mole concept. Next, equation or reaction in solutions. Reaction in solutions. Instead of molar mass, you consider this as molecular mass. And reactions in solutions. In that, molarity, mole fraction, everything will come. So, based on this, so many problems. This complete chapter is problematic only. Each and every concept from here only. Everything consists of the problems. Understand? Each and every law and each and every topic. Understood? So only these three are the theoretical part. Just you have to remember for the further classification. Further calculation. Next, except that from here everything is calculation part only. So most of the question going to ask from this chapter is problems only. Okay. So students, here in the classification of matter, as I told you, physical and chemical classification is there. In that chemical classification, we can classify the matter as pure substance and mixtures. In that pure substance, again they classified as elements and compounds, and mixtures as heterogeneous and homogeneous. Understand? Next, fundamental units means 7 units are there for length, kilo, mass, okay, weight, time, for everything. 7 quantities are there. For that 7 quantities, we have fundamental units, okay, and SI units also. Okay. Next one, powers and their prefix. As I told you, the 10 raised to minus 3 means you have to take milli. Milli is the prefix. If 10 raised to minus 3 kg is there, milligram. Okay. If 10 raised to minus 3 gram is there. If 10 raised to minus 3 meter is there, that is millimeter. Understood? Like that. Milli is the prefix for 10 raised to minus 3. Micro, 10 raised to minus 6. If anywhere they said micrometer or micrograms, that means 10 to the power of minus 6 you have to take. Nanometer, that means you have to take 10 to the power of minus 9. Understood? Those are the prefixes. Next, scientific notation and significant figures means, so listen, everything is represented in n into 10 to the power of plus or minus n form. That is called scientific notation. Understand? Each and every term. For example, 256.001 is there. It is not a scientific notation. But if you want to count the significant figures, then you have to count the number of terms which are in the given number. Okay? So here 1, 2, 3, 4, 5, 6 is there. So significant figure is 6. But for the significant figure, some rules are there. If you are only 0, then it is not a significant figure. Only 3 are there. Understood? Some rules are there. All non-zeros are significant. Some zeros are not significant. Like that, some rules are there. Later I will explain. So then there is a significant figure, but it is not a scientific notation. If you write it in 2.56 into 1, 2 means into 10. 2.56001 into 10 to the power of minus 2, plus 2, backward. It is moving, the decimal is moving backward means that is plus 2. This will scientific notation, representing in n into 10 to the power of plus or minus n form. It may be plus or minus n, because if the decimal point move backward means it will gain plus charge, forward means minus charge. Later I will explain. Okay, this is the things involved I am explaining. Next, different laws means 4 laws are there. law of conservation of mass, law of multiple proportion, law of definite proportion, and Avogadro's law. Okay. Next, calculations regarding molar, molecular masses. For example, what is the molecular mass of 1 mole, 2 mole, 3 mole, and formulas are there based on percentage. If 95 percentage, among 100%, 50% is carbon, 10% is hydrogen, 15% is something, remaining percent is oxygen, then what is the molecular formula of the respective compound then acid? So this problem is important for 3 marks. Only they will give percentage abundance, how much they are available in the nature. So based on that, we have to calculate the molecular formula of the respective compound. Okay, so that is the calculations regarding molecular mass and the molecular formula. Next, mole concept means, as I told you, 1 mole consists of a 6.023 to 10 power 23 atoms. That is also there. 1 mole of oxygen means, oxygen molecule means 32 gram. 1 mole of oxygen atom means 16 gram, because single atom means single. 1 mole of hydrogen atom means 1 gram. 1 mole of hydrogen molecule means 2 gram. Understand? So that mole concept means is equal to the atomic mass as a molecular mass. In that, molar volume is there, molar mass is there, molar what is that? Okay, volume also there, and also density is also there. Okay, so everything which is in the mole concept. If anything, 1 mole of a substance occupies some volume, that is a molar volume. Okay, 1 mole of a substance has some density, that is the molar density. Like that. And last one is reaction in solution, that is, 1 molar solution, 2 molar solution, they used to say. So that molar means how many gram of solute dissolved in a solvent. 1 molar means, okay, 10% means, how can you say 10% of glucose solution means 10 gram of glucose in 100 gram of water. Correct? 10%. Okay. Similarly, molarity for 1 liter. Okay. How many gram of solute dissolved in 1 liter? So if 1 mole of any solute dissolved in a 1 liter of a solution, then it is 1 molar. Understand? So many problems are there. Later I explain. This is very important chapter series. So I'll take so much time on this chapter also. Only this chapter, because each and everything, every chapter has a relation with respect to this chapter. Understood? Okay, we'll discuss one by one. That is classification of matter. So what is matter? Means, okay, matter means I'm asking you what is matter. What is matter? Huh? Matter is a substance which has mass and occupies space. Correct? Matter is a substance which has its own mass and occupies some space. This is also a mass. It has its own mass, that is, it acquires some space in the three-dimensional space. Okay? It has some space. So except this remaining is the empty space, you know that. So in that space, it occupies this much of place. Understand? The matter is a substance which has mass and occupies space. So in that, physical classification is there as well as chemical classification is there. This is physical classification, this one is chemical classification. So students, in the physical classification, only 3 types are there: solid, liquid, gas. Okay, this is already we studied in states of matter. So in chemical classification, we are going to study in this some basic concepts of chemistry. So that is pure substances and mixtures. So I'll explain first. The name itself says pure substances and they are mixtures. That means if any element or a compound is made up of pure substances, that means only one type of substances. If hydrogen is there, all are hydrogen. If H2O is there, all are H2O. Okay? Either element or a compound. H2O is a compound, mixture of atoms, you know that. Okay? Whether it is a element or a compound, but it consists of only one type of substances. Okay? That is called pure substances. If the mixture of two or more substances called as mixtures. Okay? If two or more substances mixed with each other, they are called as mixtures. Okay? So here in these pure substances, again element is there, and here this one is compound. Okay? Element means, I'll write the example here. H2, gold, silver, gold, N2, etc. Compound means H2O, C2H6, sorry, C6H6, that means benzene. You know that? HCl, etc. Next, here mixtures. Homogeneous and heterogeneous. Homogeneous and heterogeneous. Okay, so the example for this homogeneous is salt solution, sugar solution. Okay, salt solution and sugar solution. Example for this is oil and water. Second one is sand and water. Okay. Next. So students, here, this is a matter means, as I told you, it is a substance as mass and occupies some space. Next, in their physical classification, it is solid, liquid, gas, that is based on what? Arrangement of the atom. If it has a definite mass, shape and volume, then it is a solid. If it is having mass, volume but not shape, that is liquid. If it doesn't have any mass, volume and shape, then it is a gas. Okay. So students, next one is chemical classification. Chemical classification means how? By testing their chemical properties, their nature. For example, H2O is there, HCl is there. HCl is considered as acid, H2O is like a base. Correct? Like that. So based on nature, based on the chemical behavior, they are classified like this. Composition and all. So here based on arrangement they classified, here based on composition they classified. So in the pure substances are there. Means if the matter is made up of only one type of element or a compound, or one type of atom or a molecule, is called as what? Pure substances. Only one type. So mixture means two or more substances mixed with each other. Those are called as what? Mixtures. Okay. So in this element is there. Element means it is made up of only one type of atom or a molecule. This is atom. This is molecule. This is only one type is there. In that compound means it is made up of two or more atoms, not compounds. Here hydrogen is different atom, oxygen is different atom. But H2O is completely a compound, pure compound. Okay? Here C6H6. C carbon is another atom, hydrogen is another atom, but C6H6 itself a one pure compound. Like that. A mixture of two or more atoms constituting a compound. This is also a pure substance made up of only C6H6. Understand? So in this students compounds, two types is there. One is organic compound Another one is inorganic compound. And this one is HCl is an inorganic compound. C6H6 is an organic compound. Okay. So how can you classify them? If the compounds are derived from non-living things, then they are organic compounds. Understood? If the atoms are derived from living things, if the atoms are compounds are derived from non-living things, they are inorganic compounds. So the name itself says organic, living, inorganic, non-living. Okay? If the compounds are extracted or derived from the living beings or living things, then they are organic. For example, you know formic acid. Formic acid, you know, or in oxalic acid or citric acid, which is present in lemon. Okay? Lemon is it a living thing or a non-living thing? Lemon, living or non-living? Plants are like, you know. Okay? So that lemon is a living thing. Citrus acid, which is derived from that lemon, that is called as citric acid, that is an organic compound. Citric acid. Next, acetic acid. That is also formic acid means the acid which is present in ants, red ants. In that formic acid is there. You know, if they bite you, then you will feel some burning sensation. That is because of the acid present inside that ants. That is formic acid. So that's why it is called the acid which is derived from ants is called as formic acid. It is also an organic compound. Understand? Another one is oxalic acid, tartaric acid. Oxalic acid present in tomato. Okay? So those are all what? Derived from the organic compounds. Those are called as organic substances, that is living beings. So that's why they are called as organic compounds. This HCl, it is made up of halogen and hydrogen. They are exist at what? Seashores. Understand? So seashore is obviously it is a non-living thing. Water is a non-living thing, right? Whether it is a living or non-living, water, non-living thing. You don't have any effect. So if it is reacts with base, it acts as acid. If it reacts with acid, it acts as a base. Okay. So it is a non-living thing. So in that they are derived from non-living things. Those are called as what? Inorganic compounds. For example, NaCl salt. Okay. Cl is a halogen. Na is a metal. Metal is living thing or non-living thing? Of course, non-living thing. Halogen is also non-living thing. So NaCl is an inorganic compound. Understood? Okay. So next one is mixtures. In that mixtures, two types is there: homogeneous and heterogeneous. So students, remember here, homo means same, hetero means different. Don't think if the mixtures are made up of same type of compounds, then it is homogeneous. If different compounds, then it is heterogeneous. That's wrong. Because if it is made up of same type of atoms, then it is called as compounds. Then again they classify as a pure substance only. What is homogeneous means, you know, if you observe salt solution, okay, that is a clear solution. If salt is dissolved in water, then it is a clear solution. You cannot distinguish them as which is salt, which is water. It is completely dissolved in water. So in entire glass, you will observe only one type of layer. Whether it is a sugar solution, then also you cannot observe any different layers. Understood? Homogeneous means throughout the concentration or throughout the solution, only one type of concentration is there. That is what? Homogeneous mixture. Uniform concentration throughout the solution. Heterogeneous means oil and water acid. If you immerse oil in water, whether the mixer, okay, they form two types of layer. One is oil layer, another one is a water layer. You can observe them separately. Correct? You can easily say yes, wow, this is oil, this is water. And if kerosene in water, understand? That is also a heterogeneous mixture. Means there is no uniform concentration throughout the solution. For example, listen, if your water is there, okay, so oil droplets are here. Okay, Here the concentration is different. Here the concentration is different. So throughout the solution, the concentration is different. They don't have any same type of concentration. That is heterogeneous. Understand? If the solution, throughout the solution the concentration is same, then it is homogeneous. If uniform concentration is not there, then it is heterogeneous solution. So not only this, oil and water, sand and water, you may take sand and stone. Okay, sand and stone is also an example for a heterogeneous mixture. For example, if anyone container is there, here so much of salt is there, sorry, sand is there, here stones are there. Here so many stones are there, but only less stones are there, like this. Because they are fixed at their position, they cannot move, they are not going to dissolve in, stone is not going to dissolve in sand. Okay, if you take some amount of sand from here, means you get so much of stones in there. Understand? If you pick some amount of sand from this concentration or this part, means you get only this amount of stone in them. That means, assume this is a solid solution. It is a heterogeneous mixture, but both are solid and solid. Then also what happens here? Here the concentration is different, here the concentration is different. Understood? So that's what I am telling. So if throughout the solution there is no uniform concentration, then it is heterogeneous. Throughout the solution, uniform concentration, then it is homogeneous. So this is the classification of matter. So why I explained all these things? Because they are going to ask, what is homogeneous mixture? Give an example. What is heterogeneous mixture? Give an example. Properties of matter and their measurements. So students, in these properties, we are mainly considering the physical properties because we can measure only physical properties, not chemical. Okay? So what are physical properties means? Of course, in properties, physical is there, chemical is there. For chemical, as I told you, different laws are there. So chemical properties are measured based on the different laws and the calculation. But the physical properties, we can easily measure them by observing or using any other methods. For example, volume is there. Okay, example for a physical property, let's say volume, mass, length. These are the basic units. So students, volume. For example, if you take 1 liter of a substance, 1 liter of water you assume. Okay, if you take 1 liter of volume, if this type of measuring jar is there of 1 liter, this is a measuring jar of 1 liter. This is a container of 1 liter. Next, this is a bottle of 1 liter. This is also 1 liter, this is also 1 liter, this is also 1 liter. Okay, assume this is 5 liter you assume. This is 5 liter, this is 1 liter, this is 2 liter. So students, if you take 1 liter of the water, if you add this, insert that liquid into this, okay, or if you transfer the 1 liter of water to this measuring jar, it is 2 liter, means it fills half of this. So from this you can easily say, of course it is 1 liter. It is 5 liter, means it will be near like this. So this is 1 liter. From here it completely fills. That means this is also 1 liter. So volume, by seeing with our naked eyes, by watching with our naked eyes, we can easily measure the physical quantity by using different parameters. Okay, so this is 2 liter measurement, or the measuring jar is there. This is the container or the bucket you assume, that is water. In all them, we are easily say what is the volume of the water we are taking, or any liquid. Understand? So physical quantities means, of course, by observing only we can measure. Okay, if you don't know the measurement of the liquid, if it is a 5 liter container, if exactly half it fills means Yes, 2.5 liter is there. Like by seeing our eyes, we can easily measure them. Okay. Next, mass also by weighing. Okay, 1 kg, 1 gram, 1 ton, like that you are taking. Next length also. It is 15 centimeter, 30 centimeters, 1 meter, 30 kilometers, like that. So based on the distance, we may consider the respective that suffixes like centimeters, meter, and kilometer. That is with respect to what? Long distances. Okay, we cannot say 1 meter in centimeter, 1 kilometer in centimeter. Okay, it is so tough. That's why we measure. So 10 to the 1000 meters is equal to 1 kilometer. Okay, 100 centimeter is equal to 1 meter. Like that. Understood? Okay. So this is what means by seeing our naked eyes, we can easily measure the quantities. Those quantities are called as physical quantities. Yes, we can see with our naked eyes. That means if solid convert into liquid, it is also a physical property. Solid to liquid. Okay. If ice is there, if it melts and converts into gas, we can see. Ice to water, we can see. Okay, yes, it changes from solid state to liquid state. That is a physical property. But we cannot see. In ice, the water molecule bond is like this, very strong. They are very adjacent to each other. Understand? Okay. In water, they are far away from each other, like this. Can we see the bond between the H2O molecule in ice and water? That is called chemical properties. Chemical properties we cannot see with our naked eyes. Okay, here the bond is strong, so they are very tightly arranged. That's why it is in a solid state. So after eating, this hydrogen bond gets break and they move far away from each other, somewhat far away from each other. So that's why it is from ice to liquid it will convert. But we cannot see how the bond breakage will take place. That is the chemical property. Understand? But solid to liquid is a physical property. Whatever the properties we can observe with our eyes, those are physical properties. Whether it is a boiling point, melting point, density, understand? Volume, mass, light, ampere, current, everything is a physical quantity. So that type of 7 fundamental properties are there. What is an example? SI unit is there, fundamental properties is there. For in physics chapter, if is they are doing units and dimensions? No? Okay, listen. How you are considering? Okay. Force means you are taking what? Mass into acceleration. Okay? Acceleration means what? Velocity by time taken. Velocity means what? Distance by time taken. This is already time taken means like this. So this is completely equal to mass into distance divided by time squared. Okay? So mass is in gram. Mass is in gram or unit in meter. So mass is measured in m. The unit for mass, are you taking kg, kilogram, everything. Mass means m. Distance means l. Time means second square. If you want to write the dimension, m to the power 1, l to the power 1, s to the power minus 2. This is the dimension. Means each and every term. Force, that is mass into acceleration. Everything is written in what? Mass, length, and second. That is called units and dimensions with respect to mass, limit, and second. Each and every units can be expressed like this by simplifying like this. Understood? So these are all the basic fundamental properties. Students, what is the need of SI units and basic fundamental properties we need to know? Here we are considering mass in kg, but in abroad they are considering masses in pounds. Correct? So if you go any abroad countries, if you say like how many weight, how much weight you are means if you say 50 kg, they won't understand. If they said I am 10 pounds, 30 pounds, 50 pounds, you won't understood. Understand? So to overcome such a type of misunderstandings, they introduced an international system of unit called SI unit. Understand? So those SI units gives us the 7 fundamental units and their symbols and their units. Understand? I'll write that. You have to remember that. Only 7 fundamental units are there. Fundamental means what? Fundamental, basic. Okay, basic units. Fundamental means basic. You know, in I think in 10th standard, what is the fundamental unit of a living organisms? What you learn? Cell. It is the basic thing we need. If any microorganism is there, the fundamental unit is cell. That cell keep on multiplying and organism will form, right? Like that. For measurement also, fundamental means basic. Not only in physics, not only in chemistry, not only in biology. Okay, main. And atoms means what are the fundamental particles? Electron, proton, neutron. Those are basic. Understood? Okay. So here, length is there, mass, time, next temperature, current, especially electric current. Electric current, next temperature, amount of a substance, and last one is luminous intensity. Luminous intensity. Length, mass, time, electric current, temperature, amount of a substance, and luminous intensity. First, I write the symbol. This is the unit. Physical quantity. Next one is symbol. For length, it is L, mass M, time T, electric current electric current I, temperature capital T, okay, amount of a substance N, small n, and this luminous intensity I, I non-unique luminous intensity. Understand? So students, for these SI units, for length, what is the SI unit? Length is measured in what? Meter. Okay. Mass? Yes, kilogram. Next, time? Second. Electric current? Ampere. 1 ampere, 2 ampere. Okay. Next, temperature? That is Kelvin, not Celsius. Standard is Kelvin. Next, amount of a substance. Okay, that is mole. Okay, and luminous intensity, that is candela. Understand? The SI symbols of SI unit. Symbols of SI unit. Okay, students, meter means M. Okay, kilogram means kg. Second means S. Ampere means A. Kelvin means K. Mole means only MOL. Mole. Candela means C. This you have to remember. Fundamental units and also this one. This is the fundamental units, their symbol, SI units and their symbol. Understood? So in the tomorrow's class, I'll explain the different powers and their prefixes. Later I'll explain scientific notation and all. And in scientific notation, addition is there, subtraction is there, multiplication is there, and rounding up of numbers like 2.53 is there. What you have to take? 2.5. 2.56 is there. You have to take 2.6. Like that, rounding up of the last digits. That is also there. Everything is in scientific notation. The tomorrow's class I will explain.